So we've all gotten pretty used to chatbots, right? AI that can whip up an email or answer a tricky question. But what if AI could go beyond just talking and actually start doing things for you? That's the whole idea behind AI agents. And believe me, it's the next major leap in artificial intelligence. So let's dive in and demystify what that really means. All right, here's the game plan for this explainer. We're going to start with the absolute basics. What exactly is an AI agent? Then we'll peek inside its mind to see how it thinks. After that, we'll check out where they're being used today, the good and the bad. We'll weigh the incredible promise against some pretty serious perils and wrap up with the most important part, the quest to build them safely. Okay, so first things first, it's really easy to hear AI agent and just think, oh, it's a souped-up chatbot, but that kind of misses the point. It's a fundamental shift in what these things are actually designed to do. Probably the best way to get your head around this is to think about Tony Stark's assistant, Jarvis, from the movies. He doesn't just sit around waiting for questions. No, he manages complex systems, he executes tasks, he operates with a ton of autonomy. And that right there, that's the core idea of an AI agent, an AI that actually acts on your behalf. And here's the more, textbook definition. But the two phrases that you really need to focus on are operate autonomously and prioritizing decision-making. A chatbot just waits for your next prompt. An agent, on the other hand, is given a goal, and it's up to the agent to figure out all the steps to get there, all on its own. And this chart just nails the difference. A chatbot's primary goal is to create content. Give you an answer, write an email, maybe a poem. But an AI agent's job is to complete a task. Book that flight for me. Analyze this spreadsheet. Find the bug in this code. The whole focus shifts from just answering to actually doing. Okay, so how in the world does an agent actually do all this? How does it go from a big, high-level goal to a series of successful actions? Well, let's take a peek under the hood at the agent's cognitive architecture. Researchers basically map it out as this 4-step pipeline. Let's say you tell it, hey, plan a weekend trip to San Francisco for me. First, it taps into its memory. It knows your preferences, right? You like museums, but you can't stand tourist traps. Then it uses reasoning to break that big goal down into smaller chunks. Find flights, book a hotel, map out an itinerary. It applies its specialized skills. Maybe it knows the best way to search travel sites. And finally, it uses tools, like the airline's booking system or Google Maps, to actually execute these plans in the real world. Now, its memory isn't just one giant filing cabinet. It's actually layered, a lot like our own brains. You've got working memory, which is for what it's doing right this second. Then there's episodic memory, which helps it remember your past conversations. Long-term memory holds all that general knowledge about the world. And procedural memory is where it stores learned skills, like the most efficient way to book a flight. But here's a wild thought. To have a really good memory, an agent also has to be really good at forgetting. And this isn't a bug. It's a crucial feature. See, without something called memory decay, the agent would get totally bogged down by every single conversation it's ever had. It would make it impossible to focus on what's important right now. Okay, so that's the theory. That's how it's supposed to work. But let's get real. With all this fancy design, where are we actually seeing AI agents being used out in the wild today? Well, the applications are getting incredibly broad. The information breaks them down into 7 main categories. And they range from agents that help developers write code, to ones that can automate your web browser, all the way to super specialized agents that have deep, expert knowledge in a specific field, like law or medicine. And it's not just tech companies either. They're already being tested in the public sector. The city of Kyle, Texas is using one for 311 calls. The IRS is deploying them for taxpayer services. Even the U.S. Department of Defense is looking at using agents for operational decision-making. But it is absolutely time for a major reality check. Because for all the hype, this technology is still brand new. And honestly, it often fails spectacularly. In a recent Carnegie Mellon study, researchers tried to staff a fake company entirely with AI agents. And the result? Quote, a total disaster. Most of the agents just couldn't do their jobs. This just goes to show that we are still deep in the experimentation phase. And the Wall Street Journal backs this up, reporting that very few companies that have poured money into AI agents have actually seen a return on that investment yet. The potential is huge, for sure. But the reality today is, well, it's a lot more modest. So this gap, this chasm between the hype and the reality, it brings us to the central conflict of AI agents. the incredible promise versus some very significant peril. It's a classic double-edged sword. On one side, you have this utopian promise, right? Proponents, they imagine a world with a massive boost in productivity, where innovation just explodes and where all of us are freed from boring, repetitive tasks to focus on more creative, more meaningful work. But then there's the other side. And this list of perils is long, and it's pretty sobering. We still haven't figured out basic questions of liability, like who's on the hook when an autonomous agent makes a multi-million-dollar mistake. We don't have good answers for the risks of mass job displacement, user manipulation, or the kind of systemic failure that can be triggered in a critical industry like finance. The problem is, the more power we give these things, the greater the potential for harm. And then you have the sheer resource cost. NVIDIA's CEO estimated that AI agents could require up to 100 times more computing power than the chatbots we use today. Think about that. That has absolutely staggering implications for energy use and environmental impact. Which, of course, leads us to the most important question of all. If we are going to unleash this incredibly powerful technology on the world, how do we make it safe? How do we build guardrails that we can actually trust? This is the challenge that is defining this whole era of AI development. It's not just about making agents more capable anymore. It's about making them reliably safe and actually aligned with what we as humans want. And the answer isn't some simple one-size-fits-all content filter. The real cutting edge of AI safety is all about creating dynamic, personalized guardrails that can actually adapt to a specific user and their specific situation. This new approach is so much more nuanced. It gets at risk isn't just about what the agent does, it's an interaction between three things: who the user is, what their current situation is, and what the agent is planning to do. For example, an agent suggesting a really risky investment strategy might be fine for a professional trader, but it would be dangerously irresponsible for a total novice who just asked for some basic financial advice. And you can see how this works in practice with systems like the PSG-Agent. Think of it like a multi-layered defense system. First, a profile miner acts like a detective, learning your habits and your risk tolerance from your past conversations. Then, an input guard acts as a sentry, assessing what you're asking for right now. Together, they create personalized criteria, safety rules that are literally tailored just for you. And finally, a team of digital guardians monitors the agent's every move, its plan, its tools, its final response, to make sure it stays within those safe boundaries. And all of this leaves us with the big final question. AI agents promise to be our ultimate partners, right? To automate the boring stuff and unlock amazing new possibilities. But the real test isn't just going to be how autonomous we can make them. It's whether we can build strong enough safeguards to protect ourselves in the process.